Hi, kids. It's me, Mr. Dorfler. As you probably can see, feeling A-OK over here in the quarantine dungeon. And in fact, I think my sense of smell and taste is making a comeback as well. In order to test this, I've been eating all sorts of different foods constantly. And that's bad. That's a bad part right there, eating constantly. But it's science. You got to test to make sure your smell and taste is coming back. Anyway, we're getting there. We're getting there. So hopefully everybody's week is going just dandy. We're here for part 2 of section 2 of our videos series. So let's get started, shall we? In the first part, we got to calculate the hypotenuse, or the resultant vector of an object, in terms of its two forms of motions. Okay, it's horizontal and it's vertical motions of an object. We're going to continue that. However, this time we're going to be told what the resultant vector is, and we have to figure out the two different motions, the horizontal and the vertical motions. So this is what we call resolving vectors into components now. So those two components, the x and the y, or the horizontal and vertical, they all came together to form the resultant vector. So now we're just kind of working in the opposite fashion. And excuse me. Now, as soon as I say that, I start getting that cough, a little congestion, but that's normal everyday experience for me. Anyway, where we use the tangent of theta function in the first part, this part, since we're solving for the other two components, we're going to be using the sine and cosine functions, okay? So we're going to continue to use the vector system like we did in the first part, okay? So we're going to set up a grid system, use our vectors to draw out our motion. All right, so looking at just a small example here, we have an airplane that is flying at 95 kilometers per hour, as we see right here in our, hold on, oops. Hold on, I got to get back in here. Where did my little drawing utensil go? There it is. Okay, hopefully he comes back here. Stop. My computer has started working really slowly. Please stay there. I'm sorry, kids, but there we go. Technical issues. There we are. All right, so as we see here, with the hypotenuse being 95 kilometers per hour, that's our resultant, and we can determine what the horizontal and vertical motions of this particular airplane's path, if you will be. So the adjacent leg, so again, this leg here, will be the horizontal component, or v of x, and the that determines or describes the airplane's horizontal speed. And the opposite leg here, from our origin, is going to be our y component, or vy. It describes the airplane's vertical speed. I'm not gonna lie, this isn't the smoothest video because my computer doesn't want to work right. So that's all right. We'll get there. And you notice that theta right here, in this case, from the origin, would be 20 degrees. All right. So we could figure this stuff out by utilizing our different trig functions here. So that's where sine and cosine come in. Now, in order to find the sine of angle theta, we have to take the opposite leg and divide it by the hypotenuse, and then the cosine angle theta, that is adjacent over hypotenuse. SOHCAHTOA, remember that? SOHCAHTOA. Anyway, oftentimes in a situation like this, the sine of the function is going to be our y, or vertical component, and our cosine will be our x, or horizontal component, okay? Now, you can change that around depending on the motion of the object, what your origin is. So you have to pay careful attention to that idea. All right, so let's do an example problem here. Again, not a real long discussion here. And part 3 of this section is actually going to be a little more complicated. And that's why I'm happy that, fingers crossed, that I will be back in the classroom with everybody to go over it. All right. But here, I'm going to just move my picture there, so I have a little bit more room. We are to find the components of the velocity of a helicopter traveling at 95 kilometers per hour at the angle of 35 degrees to the ground. All right, so the first thing I want to do is I'm going to set up a grid system. Okay, and my computer is just bothering me all get out here. All right, so we'll start from the origin here. And again, I'm just kind of loosely drawing something here. But since we're using trig functions and math to help us describe the components, we don't necessarily have to worry about our exactness of our drawing here, okay? As long as we have the values that represent it, that's really all we need, okay? And so, again, drawing these correctly here, I'm actually going to change color here to yellow. So if I've got my horizontal component here, okay, again, draw my arrow. And then following the rules of drawing vectors, our second vector, our vertical vector, oh my goodness, that is just a rough looking line there. Okay, this is our Vx. And if I can draw that a little better, oh boy, this is our Vy. And again, now this is our resultant vector. And again, this is our V, okay? V is equal to 95. I've got my head tilted. 95 km per hour. This is going to be the longest part of the video, is me just trying to do this. Holy goodness. All right. So, again, we're going to take the sine and cosine function. So, we're going to have the sine of theta, and that's going to be equal to opposite over hypotenuse. So that's going to be Vy over V. Again, V is the hypotenuse here. And then our cosine, hello computer, cosine is going to be Vx over V, which is our hypotenuse. And we're actually going to rearrange this to solve for the Vy and the Vx. And so rearranging this a little bit algebraically, we're going to get Vy for this one is equal to V times our sine theta. What do you think, kids? Is it time to upgrade my Chromebook here? Because it is slow. And then we're going to rearrange this to solve for our horizontal component, our Vx. And we're going to get V times cosine of theta. Whew. Starting to get a cramp in my hand trying to use this mouse to draw this here. Okay. So now that we've got our working formulas here, to solve for Vy, oh my gosh, I did not want to draw it that big. So Vy, we have our V, which is 95 kilometers per hour, multiplied by the sine of our angle. And again, our angle was, our theta is 35 degrees. And so sine of 35 degrees, when you take sine of 35, you should get 0.57. Multiplied by 95 kilometers per hour, you should get an answer, or a vertical motion, of 54 kilometers. Making sure my handwriting matches up with this gibberish. Kilometers per hour. take some concentration on here. Okay, so that's our y component. So pretty easy, our y component there. And then to solve for our horizontal component, again, you're going to take your 95 kilometers per hour and and multiply it by the cosine of 35 degrees. And you should get a horizontal component of 78 kilometers per. Oh boy, this is something else here. Okay, so again, I drew my picture to describe, to give me a visual of the motion here. I got my vectors here. I've got them written correctly. I've got my second vector written as starting at the tail end or the arrow point of my first vector. Okay, I got my theta here. I've got my resultant vector, my hypotenuse. I rearrange these to solve for the vertical and horizontal components using the appropriate sine and cosine to go along with them. And as I said before, depending on the motion of an object, there are chances that you could be changing these up. Again, it's just got to be real careful with them. It doesn't happen that often, so just don't worry about that. Now, I will be sending out the problem bank B for this particular style of questioning, but you're going to get that the following day. So if you're really only an assignment, excuse me, is to watch. Excuse me, I'm choking on here. So watch this video, digest it a little bit. If you wanted to, you could open up to page 92 and do some of those problems, just to see, if you are getting the idea of it. And if you wanted to, you can always reach out to me to find the answers to those. In fact, I might just put a posting here with them just for the solutions, just so you have an idea if you want to do that. But really, that's it for part B here. If you have any questions, obviously, you know how to get a hold of me. I'm not going anywhere. Stuck here for a little while longer. So, in fact, if you ask me questions regarding if you want to look at the practice problems on page 92, yep, then, that'll get me distracted from counting the, strands of carpet in the basement. So, I've almost got one room completed. Anyway, I'm going to end the video with that. Again, you will be given the problem bank B for this the following day. So that'll probably be Friday for you to work on in class. And then you'll have an opportunity to post it back into the assignment to submit it. With that being said, ladies and gentlemen, A, I hope everyone's SAT, for those of you who took it, went well, because you will have already taken it by the time you get this video. And B, I hope you have a wonderful rest of your day, rest of your week, and I cannot wait to see you again, hopefully, in the next few days. Bye-bye now.